Sum rule of probability. Previously, we understood the basic introduction of probability, and the next step is to understand the sum rule of probability and the product rule of probability. So, first, we'll take up the sum rule. Once we understand the sum rule very clearly, we'll move on to the product rule. Let us start with sum rule. Assume we have two random variables x and y. We talked about random variables in the last lecture. Let us say what values x can take. Let us assume x can take different values called xi's where I ranges from 1 to m. So there are m different values that the random variable x can take. Similarly, let's say there is a random variable y which can take values yj where j ranges from 1 to l. So the idea is there are m different values that x can take and there are l different values that y can take. Okay. So what is this random variable? In case you are not able to directly relate, you can understand something like this. Let us say you have a lot of boxes of different colors. Let's say this is red, green, blue, yellow, and so on. These boxes are represented by, let us say, this random variable x, which can take many values, right? Red, green, blue, let's say m different values. Each value is xi. Similarly, let's say inside each of these box, there are a lot of fruits. These fruits can be mango, orange, apple, pineapple, so on. And these fruits, let's say, are represented by random variable y. And this y can take L different values, which means there are L different fruits. Okay. If you can simply understand it as xi and yj, it's even better. We can generalize the whole thing and understand easily. So given x and y, next thing is the total number of trials. Let's say there are n different trials done in total with these random variables. We are doing some sort of an experiment. Just assume there are n different trials done in total. Out of these n different trials, how many trials ended up with the value xi for x and yj for y? This number is nij, small letter n, ij. This nij is the number of trials in which the value of x turned out to be xi and the value of y turned out to be yj. Okay, so this combination, whenever this occurred, that total count is nij. And let us say all the trials for which value of x was some particular value xi, that is denoted by qi. And similarly, all the trials for which value of y was yj, that is irrespective of the other variable, this is considered as rj. Let us say rj is the total number of trials for which value of y was yj irrespective of the value of x, that is x1 and yj, x2 and yj, x3 and yj, xm and yj, all those add up to rj. Similarly, all the values were x took xi value irrespective of the value of y, that is xi and y1, xi and y2, all those add up to qj. This is the count, not probability, count of such events, some such occurrences. Okay. And what is nij? This is also count of all those occurrences for which x took value xi and y took value yj. And what is capital N? Capital N is the total number of trials that are done, irrespective of whatever be the values of xi and whatever be the values of xj. So to understand further, I'll draw a table. From this table, it will be easier to understand the whole concept. Okay. So let us say this is a table. And in this table, we'll have a lot of columns and lot of rows. And say in the horizontal, you take values of x. So which means this is x1, x2, x3, x4 up to xm. Okay, there are total of m different columns. Assume. Okay, and similarly take values of y in the vertical, and let's say these are y1, y2, y3, y4. These rows are these numbered, and let us say there are total of l different rows such. Okay, in this example, let's say in this particular at this particular point, value of x is xi. So I'll mark only xi now for easy understanding. Here the value of x is xi. And let us say in this particular value, here let's say value of y is yj. Okay. So what does this box represent? This box represent those number of trials in which x took value xi and y took value yj. So here the total number of trials is nij. There are nij trials for which the value of xi, x is xi and y is yj. And total sum of all the columns here, if you add up, it will give you total number of trials in which value of x was xi. And for that, what did we say? That is qi. That is, in all this complete column, value of x is xi. That you agree? Which means in total column, if you sum everything, that should be qi, the total count. Similarly, if you take this row completely, this row where values of y is yj, if you take all these together, total count is, let's say, rj. Okay. So now you have xi, yj, then nij represents the number of such trials for which x is xi and y is yj. Qi represents number of those trials for which value of x is xi irrespective of the value of y. And rj represent all those trials for which value of y is yj irrespective of the value of x. So now let us consider what is the probability of x equal to xi and y equal to yj. I'll just erase these things so that we get some space here. Let us consider the probability where x takes the value xi and y takes the value yj. Okay. What is this probability? In the previous lecture we saw probability is the fraction of times that one particular event occurs out of the total number of trials. So out of all these trials in this table, how many times did x take the value xi and y take the value yj? See this table, it is nij, right? Represented by this box. So if you take it here, it is nij divided by what is the total number of trials? That is n, right? Out of n trials, there were small letter nij trials for which x took the value I and y took the value j, that is yj. The next thing we have to see, one thing in all the probability concepts, when you write equations like this, you kind of consider that n tends to infinity. That is, there are infinite number of trials out of which this happened, but on a practical note, we take whatever is the finite number that we have in the trial. Okay. So now let us consider what is probability of x is equal to xi irrespective of the value of y. This case, what is the number of trials for which the value of x was xi? That is here, right? Qi. Qi divided by what is the total number of trials? It is n. So what is Qi here? See, be very careful. We are almost going to derive sum of rule for probability. What is the value of Qi here? That is, what is the way for you to express the value of Qi? It can be expressed as, what is Qi here? See this and see this table. Here Qi is the sum of value in this box plus this box plus this box plus this box plus this box. How would you express it in mathematical terms? Summation over all the values of j, right? All the values of j, n, ij. That is, I is restricted because you are only considering xi. J can take any value 1, 2, 3, 4 up to, let's say, up to L. So that whole summation is what Qi is. So which means instead of this Qi, I can substitute this value, right? That is equal to summation over all j nij divided by n. This is correct? You agree with this? And this nij by n, that is the probability of x equal to xi and y equal to yj. So substituting that here, this probability of x equal to xi, this becomes summation over all j, right? Summation over all j, probability of x equal to xi and y equal to yj, right? This is the sum rule of probability. The sum rule of probability says if you want to find the probability of a random variable x, where x takes the value xi, you take sum over all those probabilities where x equal to xi and y equal to yj. But what do you have to do? Sum over all the values of y, because you want to find the probability of value with x equal to xi, which is irrespective of y. So for all particular values of y, whatever is the value probability for probability of x equal to xi and y equal to yj, you can just take sum over all those and you will get the final probability for x equal to xi. The reason why it is called sum rule is that in this case, you can simply take the sum of the probabilities in order to find the probability of xi. So in simple terms, to understand, let's express it as simply as p of x is equal to sum over all y p of x y, right? Sum over all the values of y p of xy. And this p of xy, this thing may be sometimes also represented as p of x intersection y. Both are the same thing, that is the occurrences of x and y together. Okay,